nodal inspection method. So as we have seen the mesh equations by inspection method, here we can also see the nodal equations by inspection method. So here what we are going to do is, for any given circuit, we have to split it into two parts depending on the number of nodes. Okay, depending on the number of nodes, we can divide the circuit and we can write the equation of current at a particular junction, and we can find the values of the voltages and currents in that particular junction. So here we will be applying the same for our next problem. So this is a problem which is given in May 2017 for 5 marks. So this problem we are going to check whether we can use the same method or not. Okay. So for this problem, we have to find the value of V naught. So V naught is the voltage across this 1 kilo ohm resistor. So first find the nodes or junctions. So junctions we have to find so that we can apply KCL. So as you can see, there are only two junction, because junction is the interconnection of three or more points. So here the 3 points is here, so it is A, and again it is here, so it is B. So this is VA and this is VB, and as this is a common for all, you can take it as C point, but the value of VC is 0 volts. Okay, so we can first just split the given circuit into two parts, and then we can solve using that equation. So I am just redrawing the circuit at junction A. So at junction A, this is the circuit. So for junction A, what are the resistors connected? 6 volts. So this is the thing. This is A, this is B, this is 2 kilo ohm, this is 12 kilo ohm, and this is 24 kilo ohm. So here it is VA and here it is VB. So at junction, we always take that the currents are leaving. So here I1, I2 and I3. Okay, as this is a ground, so it will be 0 volts. So we can write these equations as VA minus 36 divided by 12K. So why minus 36? Because the current is opposite with the polarity of the voltage source. The current is flowing downward, whereas the polarity of the voltage source is upper terminal positive and lower terminal negative. So it is VA minus 36 by 12. Or you can also say that to know the current, we have to have a potential difference between 2 points. So to know the potential difference, it is nothing but VA minus 36. So this is I1 plus I2 plus I3 is equals to 0. So for I1 I have written the equation. Now I2. I2 is nothing but VA minus 0 by 24 kilo. Next I3. I3 is VA minus VB by 2K, which is equals to 0. So we will just write the equations of VA at one place. So it is 1 by 12K plus 1 by 24K plus 1 by 2K minus VB into 1 by 2K, which is equals to 36 divided by 12K, that is nothing but 3 milliamp. So it is nothing but 3 milli. Or you can just write it as 3 into 10 power minus 3. So this value is 3 into 10 power minus 3. Right. So here you can just compare it with the standard equation, that is this one. So at loop or at junction A, so it is VA minus V1, that is VA minus 36. So what we have written, 1 by R1 plus 1 by R2 plus 1 by R3 into VA. So VA is the voltage across that junction. So VA is the voltage across the junction into reciprocal of all the resistors which are connected to this particular node or junction. So it is 1 by 12K, 1 by 24K plus 1 by 2K. So these are the resistors connected, and minus VB. VB is the other node voltage into which is the mutual resistor. So it is 1 by 2K. So the mutual resistor between A and B is 2K. So always for mutual resistor we will be getting the negative sign. So it is equal to V1 by R1. V1 is the voltage connected to that particular loop or that particular node divided by the resistor R1. So it is nothing but that 36 divided by resistor R1 is 12K. So it is 3 into 10 power minus 3. Okay. So we just solve it. So it is 6.25 into 10 power minus 4 VA minus 5 into 10 power minus 4 VB is equals to 3 into 10 power minus 3. So this is our first equation. Now we have to solve for second equation. So here we have to mention. So now this is I3, this is I4, and this is I5. So at the junction B, at junction B, so the circuit is redrawn like this: A, B, so it is connected to, so this is 0 volts. So this is VA, this is VB, this is 2K, this is 10 kilo ohm, and this is 1 kilo ohm. So this is I3, this is I4, and this is I5. So the value of current source here is 3 milliamperes. So we know that at any particular junction, the algebraic sum of all the current should be equal to 0. So at this junction, the currents are I3, I4 and I5. So I3 plus I4 plus I5 is equals to 0. So now what is I3? I3 is VB minus VA by 2K. VB minus VA by 2K plus what is I4? I4 is nothing but the current source given, and that value is 3 into 10 power minus 3 plus now I5. I5 is the current which is flowing in this part. So it is nothing but VB minus 0 divided by 10K plus 1K. It is equals to 0. So we'll just simplify it. So minus VA into 1 by 2K plus VB into 1 by 2K plus 1 by 11K, which is equals to minus 3 into 10 power minus 3. So this also you can just verify with the standard equation. So the second equation is minus, that is mutual resistor. So VA divided by R by 3 into the resistors which are connected to that particular junction. So it is R3, R4 and R5, and which will be equal to the voltage source divided by the resistance. So V2 divided by R5. So here the value is directly given as 3 milliamps. So this equation is, so it is 5 into 10 power minus 4 VA plus 5.90 into 10 power minus 4 VB is equals to minus 3 into 10 power minus 3. So solving equation 1 and equation 2, we will be getting VA as 2.27 volts and VB as minus 3.15 volts. So these are the voltages across the junctions. Now we have to check whether whatever the value we have obtained is correct or not. So we'll be just checking at the junction. We know that I1, I2 and I3. So it is I1 plus I2 plus I3 should be equal to 0. So whether whatever the values of voltages we have obtained is correct or not, we can just verify by substituting the values in this equation. So we know that it is VA, here it is VB. So what is I1? I1 is VA minus 36 divided by 12K. So I1 is equals to VA minus 36. So it is 2.27 minus 36 divided by 12K, which is equals to minus 2.81 milliampere. Next coming to I2. I2 is VA minus 0 by 24K. So it is 2.27 divided by 24K. This value is 9.45 into 10 power minus 5 amperes. Now I3 is equals to VA minus VB by 2K. So VA is 2.27 volts. VB is minus 3.15. So minus 3.15 divided by 2K. So it is 2.71 into 10 power minus 3 ampere. So substituting it in equation I1 plus I2 plus I3 is equals to 0. So you can see that minus 2.81 into 10 power minus 3 plus 9.45 into 10 power minus 5 plus 2.71 into 10 power minus 3 will be equal to 0. So this shows that whatever the voltage values we have obtained is correct and the KCL is verified at junction A. Similarly, you can check for B and you will be seeing that the value of the voltage what we have obtained is correct and the currents, that is I3 plus I4 plus I5, will be equal to 0.
So as we have found out the currents at node A, we can also find the currents at node B, so that we can know the value of voltage which is to be known, that is V0. Okay, so let us find the values of currents at node B. So as this current value is I3, this is I4 and this is I5. Okay, so at node B, I3 plus I4 plus I5 is equals to 0. So I3 is nothing but VB minus VA by 2K plus I4 is 3 into 10 power minus 3 plus I5 is 10 VB minus 0 by 10K plus 1K, which is equals to 0. Now we know that from the equations VA is 2.27 volts, VB is minus 3.15 volts. That's what we have found out. So we'll just substitute the same values here to find the values of I3 and I5. So I3 is VB minus VA by 2K. So that is equals to minus 3.15 minus 2.27 divided by 2k, whose value is minus 2.71 milliamperes. Similarly, I5 is VB minus 0 by total 10k plus 1k, that is 11k. So it is equals to minus 3.15 divided by 11k. So it is equals to minus 2.86 into 10 power minus 4 amperes. So substitute these values in I3 and I5 so that we can check that the value of current at that particular junction B or node B is equals to 0. So minus 2.71 into 10 power minus 3 plus 3 into 10 power minus 3 minus 2.86 into 10 power minus 4, which is equals to 0. That means here also at node B or junction B, KCL is verified. Now we want the value of V naught at this 1 kilo ohm. So V naught is nothing but, that is the voltage is nothing but the value of the resistor and the current flowing through it. So the current is I5 and the value of resistor is 1 kilo ohm. So I5 is nothing but minus 2.86 into 10 power minus 4, 2.86 into 10 power minus 4 into 1 kilo. So 1 into 10 power 3. So whose value is nothing but minus 0.286 volts. Okay, its value is nothing but minus 2.086 volts. So as the polarity here it's plus minus, but actually the polarity should be plus and minus.
So this is how you can solve the numericals, either using inspection method or you can write the equations also. Thank you.